Alrighty then, corn children, children of the corn. Today we are going to have our lesson on binomial expansions. Now, if you have not already looked at, watched, and enjoyed my videos on combinations and Pascal's triangle, stop what you're doing right now and go back and watch those. They lead into and explain steps in this video. Yes, there's an order to this. All right, so I'm assuming at this point that you have watched those and you have looked at those. So what are we doing today? All right, today we are looking at binomial expansions. Binomial, two terms, like x plus y. And we're going to be raising them to different powers. Now, the n power needs to be a whole number. We are going to be looking at what happens when you have x plus y to the third. How do you multiply that out quickly and efficiently? How do you do x plus y to the fourth? How do you do x plus y to the fifth? And so on. Now let's be clear. I hesitate to even write this down. It makes me sick to even think this is something you might do. Let's be clear. It is not x squared plus y squared. That would be foolishness. What does this mean? It means you write it twice and multiply it out. But we're going to see there's a way to do all of that without actually multiplying it out. So let's just start with some basic rules. Now I've included these basic rules in a worksheet, but you can pause the video and write them down if you need to. All right, when we multiply this out, here we go. Going to go through this quickly. You can pause it, do what you need to do. When we multiply it out, the number of terms in the answer will be this exponent plus one more. So if this is a fourth power, you have 5 terms. Next, we will arrange the terms in order. We will take the lead term and put it in descending order, beginning with power n. If this is a fifth power right here, your first term will have x to the fifth, then x to the fourth, x to the third, and so on. You'll get it, don't worry. The back term will be put in ascending order, beginning with power 0. So the first term will get no y's at all, then y to the first, y to the, and so on. All right, coefficients will come from Pascal's triangle or combinations. That's why you have to look at those videos. Simplify each term and put appropriate signs in between. I forgot that one. That's it. Ta-da! All right, so let's take a look at this process. You'll get it. You'll get it. You'll get it. We'll do enough of them. It'll be fine. This is not a difficult lesson. Honestly, things could be worse. All right, let's look at our first example together. What if we had x plus y to the fourth power? Now, I could, if I hated myself, write down x plus y times x plus y times x plus y times x plus y, and then multiply the heck out of it. Not gonna do it. All right, so the first thing is number of terms. If this is a fourth power, we will have 5, 4 plus 1 is 5 terms. So I'm just going to make 2, 3, 4, 5 spaces. 5 little spaces. Those represent the locations of each of my terms. Fourth power, 5 spaces. All right. The lead term is x. You start by taking x, whatever's in the front, and putting it in descending order, starting with 4. So this is x to the fourth, x cubed, x squared, x to the first, no x's, no soup for you. Hey, that wasn't so bad. We can do that. Now we take the back term. Now listen to me right now. Don't look at the sign in the middle. We will tackle that at the end. I'm ignoring the sign, whether it's a plus, whether it's a minus. I'm looking just at the back term, absolute value, no sign. we put that term in ascending order. Now here's the tricky one, people. This is the tricky one. You get no y's at all. No y's in the first one. Then y to the first, y to the second, y to the third, y to the fourth. Well, that's pretty easy too. I know, right? Now, to figure out how many of each of these terms we have, we will go either to Pascal's triangle or use combinations. All right, here's how this works. If we are looking for the fourth power, we will use the coefficients, this should look familiar, from the fourth row. All right, remember row 0 is at the top, row 1 is here, row 4 can be easily identified by having a 4 in it. Also, how many terms do we have? 5. 1, 2, 3, 4, 5 numbers. So you need to pick the correct row. Our coefficients are 1, 4, 6, 4, and 1. Alrighty, so let's drop those in. Here come our coefficients. Let me get a pen. This will be 1, 4, 6, 4, 1. Awesome. All right. Now in this particular example, I've done an easy example with you. Each one of these terms is already fully simplified. If I look at 6x squared, y squared, there's nothing I can do to simplify that. So that step does not occur in this particular problem. All right. However, we do need to address now the sign in the middle. You remember we started by ignoring it? Well, now we look at it. If this is a plus, each term is separated with a plus. Here's what I'm telling you, people. If you take x plus y times x plus y times x plus y times x plus y and you multiply it all out, this is what you get. You get the answer, x to the fourth, 4x cubed y, plus 6x squared y squared, plus 4xy cubed, plus y to the fourth. That was pretty painless. Yeah, this one wasn't too bad. We're going to make it a little bit harder now. I'm going to put some more numbers in here, but that's your process. All right, let me also just backtrack a little bit. Please recall that you can create the fourth row of Pascal's triangle without making the entire triangle. If you need to, go back to the video, go and look at it one more time. But bottom line, you can go to your graphing calculator, go to your y equals. If you want the fourth row, you want a 4 right there where the cursor is flashing. You do 4, that's the combination of n things chosen r at a time, and you put the variable x using your variable key. Then you set up a table. Let me just show it to you real quickly here. That's what the table setup should look like. You start with 0, go by 1, and then you look at your table. And there we see the fourth row of Pascal's triangle, 1, 4, 6, 4, 1. Hey, that's what we used. I know. All right, so let's do one more of these quick like a bunny. All right, here we go. Let's try x plus, no, let's use a minus. Minus, that's a minus sign now. X minus 2y to the fifth. All righty, here we go. Fifth power, 6 terms. 1, 2, 3, 4, 5, 6. First term, descending order. X to the fifth, x to the fourth, third, second, first power, no soup for you. Now the back term, don't look at the sign, ignore the sign. 2y. Both the 2 and the y in ascending order. No 2 y's. 2 to the first, y to the first. Now check this. 2 squared, y squared. Each of those gets squared. 2 cubed, y cubed. 2 to the fourth, y to the fourth, 2 to the fifth, y to the 5th. All right? These are all little multiplies in between each of these in each term. Alrighty? Pascal's triangle. I am going to the 5th row. The 5th row of Pascal's triangle. 1, 5, 10, 10, 5, 1. So I'm going to drop those in. I'm going to put them in here. 1, 5, 10, 10, 5, 1. Alrighty, now pay attention, pay attention. This time it's a minus sign. When it is a minus sign and we haven't used it yet, do you see how we have not used it yet? We put alternating signs between these. This is a little tricky. Focus. The first term is positive, then negative, positive, negative, positive, negative. All right? So when it's a minus, the signs alternate. Beginning positive. All right, we do need to simplify though, and you might want a calculator for this. Yeah, you might. All right, first term we're good to go. It's just x to the 5th. Minus sign. Next term, when you multiply, the order doesn't matter. So we can multiply the 5 and the 2 even though they're not next to each other. That's a 10, people. 10 x to the 4th y is the simplification of this term. Plus sign. Next term, do you see that? That's a 2 squared. So that's 4 and 10. That's 40, people. If you don't believe me, use your calculator. Minus sign. Look here, there's a 2 cubed. That's an 8. 8 and 10 multiply to make 80. All right, here we go. 2 to the 4th times 5. That's 16 times 5. That's also 80. How'd she know? Yeah, I'm a math teacher. Gosh, I hope that's right. Yeah, it is. Okay. Next up, we have the minus. There's the minus. 2 to the 5th. Y to the 5th. Ha ha. Now that might seem a lot of work. Let me tell you, it's a lot easier than doing x minus 2y multiplied out 5 times. Trust me on that one. Or not. Do it yourself. All right, there it is. Enjoy.